Okay, we wrote down all sorts of stuff. We actually really did get a lot done. In that, we needed to grade section 10.3, so when we finish early today, which I'm fully expecting to do as long as we focus and work together and get things done. I am going to check sophomores 10.3 because you were excused yesterday since you weren't in here. So I'll spot check your 10.3. So maybe for the first time you're like, oh, this is what it feels like to kind of have homework done. Yeah, that's how it's supposed to feel all the time. Anyway, so let me back up. 10.4, we were able to get graphs down for hyperbolas. We were able to get standard form equations down. We were able to do some examples of if we have clues, how to get an equation. More clues, how to get an equation. We are going to go to this one, but kind of like we did for ellipsis, even though, oh, that's not the right one. My board is not oriented. We're going to have to fix this because it's going to be rough.
Yeah, Nathan moved it yesterday. I just wanna say that.
What would I say? Unoriented, disoriented, right? Itself without any help, so don't worry. It's not.
Well, we can blame Nathan, right?
Yeah, every teacher. Be nice to run. Okay. Here, we do have one more hard example, but before we do the hard example, let's do an easy example, especially because a lot of you guys weren't here yesterday. We had more sophomores than I realized. Because I don't identify you guys as your grade, I identify you guys as who you are. So, anyway. Aw, shucks. Okay, so we're about to give you the following. I have to say sketch the following conic section. I'm going to give you the nice by hand version. Remember, every conic section can have a nice calculator version where like all the x's and x squareds and y squareds and x terms and y terms have already been simplified for us. But then there's also a nice by hand version, which is what I'm about to give you. Let me give you, let's see, y minus 1 quantity squared, that's 2, all over 9 minus x plus 2 quantity squared all over. I'm going to give nice square roots, otherwise it just gets messy. I'm saying just 4. Usually 4. Equals 1. Let me go ahead and really quickly do a full screen just so you can see it better. Let me quickly go ahead and do an entire page so I can make it bigger. And there we go. So, if I wanted you guys to identify, and I want you to sketch, that's true. But sometimes we have to kind of plan ahead to sketch. And sometimes they give us an equation, they don't just want the sketch, they also want the different characteristics identified. Like the center, like the vertices, what else is important? Like the foci. What else can you do for hyperbola? Ooh, like the equations. This is where some of you might get stuck in homework of the asymptotes. You guys know it's not really how you say that, right? We talked about this? Okay. So, do you guys still snicker when I say it the normal way so like I get it? I don't want you to go to college and be like, asymptotes, and someone's like, You say your teacher this one. You're going to say that, right? Like, blame me if something ever comes up. They just blame us, we don't mind.
You do that? Sweet.
No, like the thing, like if you ever get stuck in it and you're like, I just need to leave, like whether it's a party or whether it's a friend's house, like don't worry, just blame us and get the bad guys will come get you. Like, oh, my parents wouldn't want me to. Maybe not. Okay. What can I pull out? What is the center? Oh, 1, -2, that's easy.
Yeah,
What's the center?
-2 and 1.
-2 and 1. Why?
Because the x is not.
What goes with the x, what goes with the y? You have to remember, hyperbolas, they can switch positions, so we have to make sure we're taking the x for the x and the y for the y. Which way is this hyperbola oriented? Looking at the positive term, looking at which one comes first. Is it going to be an up-down or a right-left? Up-down, because the y comes first. And up-down because the y comes first. Let me get some points. Okay. We can put our negative 2, 1 in, right? Now what?
We have A and B.
I can find A, I can find B. What do I do with those? I can see 9 is 3 squared and 4 is 2 squared, but what do I do with 3 and 2?
Oh, you make the
Which one makes the vertices? Which number? Which number? 3. If you look at the positive term, the one that determines is going to be an up-down because the y comes first. The one that determines is going to be an up-down because the y comes first. Think about us making a y. Hey, look. Anyway, so since the y determines the orientation, the y will also help me with how far up or down to get to my vertices. So how far am I going up to get to vertex number 1 for the first branch?
1, 2, oh.
Why am I going 3? Because A is 3. 3 squared is 9. How far am I going to go down? 3. Because A is 3, right? And it kind of makes sense up, down, because it's underneath the y value. Isn't the y value always up, down stuff?
Yeah.
Vertical measurement. What did we do with that 2? We did something with the 3. What did we do with the 2? We can mark our vertices. I apologize, we can do that. It's be negative 2, 1 plus 3 is 4. Negative 2, remember, we add and subtract from the y's. 1 minus 3 is negative 2. You can also count and then figure out where they are as well. But what do I do with asymptote? Yeah. We use the 2 for the asymptote. We don't use it for the foci. Well, we might need to use it for the foci. But we're going to use the 3 and the 2 for the asymptotes. We'll get back to this in a second. If I'm trying to figure out the slopes, I have this 3 underneath y terms. I have this 2 underneath x terms. Do you guys remember how we make the slopes of the asymptotes? Slope, rise over run. Something on top, something on bottom. 2 asymptotes, any plus or minus. I'm trying to just logically kind of guide you where you're supposed to go. It's not the center. We're using our dilations to help us get there. Who goes on top, who goes on bottom? YA. Because it's underneath the y. It has to do with vertical rise. Right? Change in y over change in x, so you take the y one. Not literally y sub 1, but you take the y coefficient, which would be 3. Rise over run, the run coefficient will be 2. That's where the b gets used. Although maybe there's another place the b gets used. We still haven't found our foci. Okay, well, what's that important letter to go with foci? Not P, that's for parabola, that's C. What's the equation for hyperbola?
Oh,
A squared plus B squared. So C equals the square root of 13. It's true. It's not pretty, but it's true. In this specific example, with the y squared term coming first, and the hyperbola vertically oriented, and the vertices vertically apart from the center, where do you think the foci are going to be? Vertically apart or horizontally apart? Vertically. Everything's vertical in this one. So then, square root of 13 kind of does help me out. Less than square root of 16, more than square root of 9. What's that in between-ish? Come on, make us some math, because I know you don't like it. Sometimes I say this and I just get blank stares. Usually. Estimation is one of those things elementary math is supposed to help you with. Maybe for some reason it got lost. The square root of 13. Guys, what's square root of 16?
4.
What's square root of 9? 3. So I know it's 3.5-ish? Who's plugged it in yet? What is it exactly?
3.605555.
So we guess 3.6. It is not exactly halfway between. But at least you know kind of how to put it on a graph, right? So I'm going to go 1-ish, 2-ish, 3-ish, and a little bit more-ish. Okay. little bit more-ish. Not a lot more. It's in between 3 and 4 somewhere. That's okay, it's good enough if we're doing it by sketch, a sketch by hand. But how do we show our foci over here? We make it exact, we make it precise. And we say, okay, take the y value, vertical, and add square root of 13, right? And subtract square root of 13. Just keep it precise as you write down the points. But when you sketch them, 3 and something-ish, 3.5-ish is enough. So how do I make my hyperbolas? Do they touch the center? Do they touch the foci? Where do they touch? Oh, okay, so this is good? What else do you need to consider?
Asymptotes.
Asymptotes. So the last thing we're missing is are the asymptotes. Let's check out their slope. From the center, going up 1 and a 2 and a 3 and a over 2. Down 1 and a 2 and a 3 and a over 2. But not just positive, what else? Negative. So down 3, over 2. Oh, that's what was wrong. I drew a little too high. I see a tick mark somewhere in here. Now what can I do? Yeah, I can draw my hyperbolas now. Now some of you guys might have learned, once again, to go up 3, down 3, right 2, left 2. And you might have seen before someone make the box. And the box, you can draw the asymptotes by just connecting the 2 different sides. I don't necessarily do that because it's not how we normally draw asymptotes, but it can work. I'm just trying to show you there are 2 separate lines coming from the center with a slope of 3/2. And then we can go ahead and say, all right, touch of the vertex, skin the asymptote. Touch of the vertex, skin. Touch of the vertex, skin. Touch of the vertex, skin. Is it perfect? Not necessarily. Is it awful stinking close? And the answer is yes. But there is one thing we haven't answered yet. We've gotten our sketch. We've identified all of our clues. We've gotten our center, our vertices, our foci. What we haven't gotten are our equations of our asymptotes. We've gotten the slope, but we haven't gotten the equations. How do we make equations of lines? Of x plus b, but do we know exactly where the intercepts? Yeah, let's use point slope. Because point slope is y minus. What point do I know these asymptotes both go through? Center. So steal your center, y minus y1 equals m times x minus a -2, x minus x1. Good enough. If you use the calculus, we'll just stop there and say, good enough. Unless it's like a multiple choice and we have to match it and they made it y equals mx plus b. Which you guys will kind of experience if you check in the back of the book. I bet they will have made it y equals mx plus b. But this is the easiest way to set up. You know it goes to the center for both. You know the slopes are plus or minus. Dilation into the y over dilation into the x. Alright kiddos, that's the big idea of hyperbolas. From a standard form equation, pulling out the clues, how they relate to the graph of the hyperbola, and all the different pieces from the center and the vertices and the foci to the asymptotes. So let's just see this one last example we've been working up towards. Why is he one step harder?
Because you have to find the perfect squares.
Not necessarily one step harder.
One category? There's an
One
extra-
tremendously long step.
Oh, what?
Chill, kid.
But wait. Yeah, take 63 the other side. Remember, he's the constant with everything put together. I need to make my own constants. Don't we usually put the x squared one first, though? Why wouldn't I for this one?
Because it's not that. It's horizontal.
He's the minus. So think about hyperbola. Isn't he going to go second?
Yeah.
Okay, so we're going to put the 16y squared together with his y term. Then we're going to do minus. I'm just trying to show you the idea for the hyperbola. Remember, you need a positive term minus a term. So I just went ahead and pulled that negative out of both the x terms. So I need a big old minus and then the x's to come. Maybe this reminds you you're supposed to pull out whatever's in common for these terms. 64 divided by 16 is 4, I believe. Or I should say I agree. This one, there's nothing else to pull out. The negative was basically the only thing. What am I leaving room for?
Square.
Completing the square. So, complete the square. Take the middle term, divide by 2 and square it, right? So what's going in? 4. And who was the square that made 4? 2. And the whole point is to make a perfect square. Y plus 2 times y plus 2 will be y squared plus 4y minus 4. Sorry, plus 4. Minus, take the middle term, put it in half, square it. Negative 1 squared is positive 1. Negative 1 was squared to get there. And to finish completing the square, we say, what did we really add on this side? Well, we added a 64, and we subtracted a 1.
Oh.
Is this good, or is this bad?
It's not very, better than like 2 or 5.
What are we supposed to get over here?
We're supposed to get 8.
Or a number that we divide to get 1. Can we divide by 0?
No, so there's.
You guys have just come in contact with, at least in class, your first degenerate conic. Huh? He's degenerate. He looks like a conic. He looks like a hyperbola. If I were to go ahead and think about, hey, a squared and a squared and a minus, it's a hyperbola all day long, but it's not. I tried to make it a hyperbola. There's a 0 there. Now, it's not nothing. It's not nothing. No, that's right, because it is something. It's not nothing, but what is it? Well, we gotta start solving for something and say, well, hold on, I can't tell who this guy is in the form that he's in because I was getting ready to make him a hyperbola, and he's not. What on earth? Can't I legally square root both sides? Because I have a square, I have a square, I have a square, and there's no addition or subtraction splitting them up and making it illegal like the killing of the puppy on the wall, so, okay. Plus or minus square root that side, and plus or minus square root that side. Oh, I can't necessarily cross that out because I need to also take the square root of 16, which is 4. So I'm going to have 4 plus or minus times y plus 2 equals, I'll repeat that, plus or minus x minus 1. This might look a little weird because I have plus or minuses on both sides. Ultimately, you can think about all the different combinations. Positive over positive is positive, positive over negative is negative, negative over positive is negative, negative over negative is positive. You end up like moving the signs to say, okay, no big deal, just move it to one side. This was all a really snazzy and kind of transformed weird to make me think it was a hyperbola. It's just a line. How many lines?
1.
Why 2?
It's plus or minus.
Oh, plus or minus.
It's 2 lines.
I'm sorry.
Sneaky little devils, look at them. I can divide by 4. And I think I have a point slope. I can even graph the little boogers if I wanted to.
But you don't.
Well, I probably should. But what am I going to say is my center? Vertices. Foci. Equations of the asymptotes of the hyperbola. I'm just going to say they're 2 intersecting lines. And that's why earlier we said that there are some degenerate conics in that they might appear intersecting, not intersection ones. I can dress up like one of the other conics, but when you start to simplify, it's not going to be able to be one of those conics. Something is going to happen. Usually it's equaling 0. And so when you go down to solve, it ends up being something else. So if I was to graph this, I would say point slope, no big deal. Go graph that point. I have the point 1, -2. I have the slope of plus or minus 1/4. I can go to 1, -2 and make a point. I can go ahead and say, sweet, up 1/4. Down 1. Left 4. So up 1, left 4. Over, down 1, over 4. Oh, they should be solid because those are the actual graphs. Just pretend I can actually type it up on a smartboard. Done. Kiddos, we still have, 10 minutes. At least it's a good amount of time. Let me go ahead and show you guys your homework. I want to make sure it's the most up-to-date version. I think I might have a different version in your notes. Starred. Sophomores, I'm going to come around and spot check your homework number 62. And if I were you guys, open up your spirals and let's get this written down. Just for sake of time, because I know that some of you don't have your books in class, let me go ahead and as this is loading, let me see if I can get my book loading. That'll be faster than all of you guys running to your locker borrowing all my books. But if you do want to borrow a book, that's totally fine. Just run to your locker, as long as it's close. I don't mind. It's coming. Come on. My computer wouldn't freeze.
That's pretty cool.
Okay. Alright, there it is if you guys want to write it down, and as you do, I'm going to freeze the screen and try to get the book up. Because most of you probably wouldn't go any farther. But if you do want to borrow a book, there are like 5 up here. I don't mind. Just come quick. Come on, come on. Yeah. I forget you guys are in the hallway, most of you, so that should be easy to get. Where are we, 10.4?
Hey Tyler. Look, you know how the song is?
Alright, is anybody still writing down? 5, 4? Oh, 3?
The only one I remember is at the end.
Is it matching?
That's the only one.
I think so.
How did it start?
You guys ready? Come on now. Do it for a friend. Alright, kiddos, take it away. There's a lot of the homework. Sophomores, I'm coming. Abby, do you have your 10-3 ready? Ashley, do you have 10-3 ready?
Yeah.
Hey Nathan. Nice. That's not the worst thing.
Hey, Caleb, I'm gonna make ice cream today too.
Naomi's gone too.
Gotta hurry. It's
Is Leanne doing her ice cream again?
Yeah,
Throwing the bag?
Is that today?
but I'm an AP Chem student, so I get to do it anyway.
How does this sound go?
Okay.
Sorry.
You guys are in the right place.
I just have to get out of some period PE.
Legally or illegally?
Technically legally, but I wouldn't mind getting out illegally if it means I get ice cream.
Fixing out
How are you supposed to find? Are you supposed to find the?
Oh yeah, it's right there too, Mike. Through the process. Exact representation. 20 something.
What is it? Something all things wise powerful, sustaining all.
Sustaining all life through the powerful word. Jesus profit from
Doing alright.
Yeah. You know it?
Some men.
Oh, yeah. Still don't get these freaking seconds.
You can give it a little bit. Not too much.
I'm making my own song for it.
Mine's like growing.
It's just like such great
Wait, what was after the 5 years?
Tyler, you're making ice cream today too?
Well, not really, but yeah.
Did you get gloves though?
How much more?
Tyler, did you bring gloves?
Nathan. How much more comes after?
It's a little dead.
Alright kids, any more corrections need to be turned in? Make sure you do it before you leave. Otherwise we have like 5, 7, 8, something minutes. It can be used on assembly day.
There's so much. What is this? What does he do?
These are old versions.
Yeah.
Oh wait.
So long.
Uh-oh.
Who else was gone? Naomi's gone.
Ricky's not.
Alright, drink the lips over.
Or is he sitting in a different position?
Alright, I still have to, wait, do we get out at all?
It's a little bit later because it's assembly. Oh, it's like
It's like 47, right?
36. You guys still have 10 minutes.
Laser.
Nice. Can I please? Maybe I'll
Yeah, I have a laser printer.
finish my
Yeah.
I didn't finish the one.
Yeah, I got it for my birthday.
Are you guys missing anything? Do I need to? You don't have 16
Yeah,
days.
it's number 1 on my birthday list.
Yo, Big J.
Never mind.
Tell me to do 10.
My mom actually said probably
What?